Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 6, 2025, about 2 days ago. It shows that translating game rules into executable code world models and planning with Monte Carlo tree search outperforms or matches Gemini 2.5 Pro in 9 out of the 10 considered games. The paper is titled Code World Models for General Game Playing. And as we'll see later, the implications for reliable, strategic play are pretty significant. This paper uses a large language model to write Python game engines and heuristics, enabling verifiable legal moves, deeper search, hidden state handling, and stronger generalization. The introduction set up why code world models matter. Figure 1 shows how accuracy improves as the number of large language model calls grows under tree search refinement with hidden history inference. The left panels report transition accuracy, which climbs fast to near perfect for most games, but stalls for Gin Rummy. The right panels track inference accuracy, where Gin Rummy stays near 50%, and Hand of War rises slowly to roughly 3/4. So Figure 1 showed the learning curves. Table 1 reports the accuracy numbers for the imperfect information games with hidden history inference. Transition accuracy stays perfect or near perfect for all but Gin Rummy, which trains at about 0.78 and tests at about 0.75. Inference accuracy is similarly strong except Gin Rummy, which tests near 0.54, yet rises online to about 0.97. The two out-of-distribution games, Quadranto and Hand of War, remain highly accurate. Gin Rummy also demands far more large language model calls, roughly 500. So the previous table summarized accuracies. Figure 2 shows game results for perfect information play. The code world model with Monte Carlo tree search matches the ground truth Monte Carlo tree search across backgammon, Connect 4, tic-tac-toe, generalized tic-tac-toe, and generalized chess, which signals high rule fidelity. The agent consistently beats Gemini 2.5 Pro while random opponents are swept. Forfeits are rare, and generalized chess remains competitive but not dominant because draws and mixed outcomes appear. Alright, the previous figure summarized perfect information play. Figure 3 presents open deck imperfect information results. The agent generally matches or beats Gemini 2.5 Pro with strong wins in Quadranto and solid gains in bargaining. Le Duc Poker shows better average returns but high variance, which signals swingy outcomes. Gin Rummy looks chaotic because the baseline is very weak and forfeits are common. Hand of War remains the main weakness, with losses dominating. Okay, the previous figure summarized open deck outcomes. Table 4 reports transition accuracy and large language model calls for perfect information games under tree search refinement. Accuracy is essentially perfect across train, test, and online, with backgammon testing at about 100% and the rest at 100%. The out-of-distribution entries are generalized tic-tac-toe and generalized chess, which still achieve perfect accuracy. Large language model calls vary a lot, with backgammon needing about 17, while most others require only 2 to 5, which suggests easy refinement for simpler rules. So the previous table covered perfect information. Table 6 reports imperfect information results with hidden state inference. The table shows generally high transition accuracy, yet bargaining drops online to about 0.87, which signals some brittleness. The Gin Rummy row stands out. Transition accuracy trains near 0.89 and tests near 0.82, while inference tests around 95% and climbs online to about 97%, with roughly 500 large language model calls. Quadranto remains near perfect across all columns. So the previous table covered hidden state inference. Table 7 shows win rates for perfect information games against 3 opponents. The code world model with Monte Carlo tree search matches the ground truth planner closely, which signals that the synthesized rules are accurate. The agent consistently defeats Gemini 2.5 Pro across backgammon, Connect 4, tic-tac-toe, generalized tic-tac-toe, and generalized chess. Random opponents are swept, as expected. Forfeits appear only rarely, so illegal moves and crashes are largely eliminated. Wrapping up, 2 takeaways stand out. Translating rules into code world models enables verifiable play and deep Monte Carlo tree search, and this combo beats or matches Gemini 2.5 Pro in 9 of 10 games. The broader implication is clear. Treat large language models as simulator riders for safer, stronger decision systems. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.